In this video, I'm going to show you how to get the right boundary condition matrix every single time without entering all of the zeros manually. So I'm going to start out with a truss here. So this particular truss has 3 nodes, A, B, and C. So up here I've just put in 3 nodes, and because they're truss elements, they have 2 degrees of freedom. Each type of element has a different number of degrees of freedom, and the degrees of freedom mean different things. I'm going to go ahead and use those 2 things to create an identity matrix of n number of nodes times n the number of degrees of freedom, and I have singular here, node, number of degrees of freedom, and it creates an identity matrix for me with 1s on the diagonal and 0s everywhere else. I'm now going to go ahead and I'm going to take that and I'm going to select all of it. And I'm going to go ahead and copy that, and I'm going to paste that value down here into my boundary conditions. It's important to note that I need to copy and paste an identity matrix and not just define boundary conditions as an identity matrix, because then it won't let me edit the boundary conditions. I don't want that little thing there, I just want this. And it's worth noting here that each of these rows and columns in the identity matrix corresponds to a node on our truss. So the first 2 rows correspond to the x and y degrees of freedom for node A. Rows 3 and 4, the x and y for node B, x and y for node C, and so on. And then the columns also correspond x and y for node A, x and y for node B, and so on. So now we're going to look at the truss and think about our different conditions. So at A, we have a pin, which means that there is 0 deflection at A in both the x and the y directions. And at B, it's free to deflect in both the x and the y direction, so we're going to leave the 1s there. And then for node C, we're constrained in the y direction vertically, so we'll go ahead and leave the constraint in the x direction, and we make a 0 in the y direction. So now I can go ahead and I can select my columns, delete the columns that have 0s in them, and there I have a boundary condition matrix that has all of the right columns, and I can use that in the rest of my analysis. So hopefully that helps you make a boundary condition matrix, helps you understand what goes where. Leave your questions in the comments or bring them to class, and I'll see you there.